So this is the massive text embedding benchmark leaderboard that we've got here. So this is hosted by Hugging Face. It basically benchmarks all the different embedding models from here. So we can see that one of my favorites for a long time has been the Instructor XL embeddings in here, but we also have some of the OpenAI embeddings in here. So just quickly, I thought I'd do a timeout and tell people why I think you probably shouldn't be using OpenAI embeddings. So there's a lot of confusion out there about embeddings and embedding models. You certainly don't need to use the same embedding model provider. So if you're using OpenAI GPT-4 or GPT 3.5, etc., that doesn't mean you have to use OpenAI embeddings. In the same vein, there are some projects out there that are taking some of the Llama models and trying to turn them into embedding models. That probably doesn't make sense for most projects. The embedding models are trained to be embedding models, meaning that while they've had they've had a lot of pre-training, they're also usually tuned in a way so that they can take text and find the similarities, etc. So you don't want to just go out there and look for, like I saw recently, a bunch of people talking about a Llama 2 embedding model. That's probably not going to be the key thing. So why do I recommend that you don't use OpenAI? So first off, if you look at the OpenAI model down here, it's way behind the open source models now. Things have moved on. But that's not the main reason. That's certainly one good reason, is that you can get other models now, including some of these models that are very small, like these GTE base, the BGE small, etc. These are small enough that you can probably run them on a CPU as well. So you don't even need to worry too much about going hardcore for a GPU, etc. One of the big reasons, though, that you don't want to use this model is that you don't want lock-in to a certain provider. So all the other models here are open source. You can download them. You can use them on any platform. You can use them on any hardware, etc. The moment that you're using the OpenAI embeddings and you basically embed a large corpus of data that you're going to use in the future, you're going to find that's going to lock you in to having to use those going in the future. Otherwise, you're going to have to start from scratch and re-embed everything again. Now, of course, that's something that you can do. It's going to be costly if you're having to pay for all these embeddings as well. Another issue is that at some point, probably not that too far off in the future, OpenAI is going to deprecate this model because they're for sure coming up with better models as well, as everyone else is coming up with better models. And when they deprecate this model, there'll be a certain time overlap where you can probably use both or something. But again, you're going to have to re-embed everything from scratch. So I do think that the OpenAI embeddings can be useful if you want to just quickly test something out. You just want to use an API, you want to ping something. Okay, sure. In that case, use it for testing, use it for trying out an idea, etc. But for long term, if you're building a major project, I think you really want to go with open source embeddings. All right, let's get back to the BGE embeddings. So just as of the past few days, we have a new leader on this leaderboard, and these are the BGE embeddings. So in this video, I'm going to go through looking at the BGE embeddings and using them with LangChain to do some retrieval QA with a Chroma vector store, and we're going to look at putting all this together. So let's jump into it. What are the BGE embeddings, I hear you say? Well, these come out of the Beijing Academy of AI, and they're basically a new set of embedding models that they have released. And you can see here, looking at their GitHub, we can actually see that these embeddings, they've got both an English embedding and a Chinese embedding. But the other interesting thing is they're also working on a multilingual embedding, which is not out quite just yet. So these have skyrocketed to the MTEB Leaderboard just in the past few days. One of the things that I love about these is the size. So the Instructor XL embeddings that I've been using up until now, just under 5 gigabytes for the size. And you can see that these are now no longer near the top of the leaderboard. The BGE ones that we've got not only are scoring much better, but they're tiny in comparison. So the one I'm going to use today here is going to be the BGE base English model, which is about 1/10 the size of the actual one that we were using with the Instructor XL. Now you could go for the large model, which is just over a gigabyte, and the embedding dimensions of that are actually bigger as well. You're probably going to find that for a lot of things that the 768 dimension embedding is quite standard. And this is what I'm going to use with Chroma and with LangChain in this to look at how does it perform compared to those InstructorXL embeddings that we were using before. Just to refresh what I covered in the last video, we're basically using the Llama 2 70 billion model hosted on the Together API. I'm not going to change any of that. Bit that we were using the embeddings there before was we were using these Hugging Face instructor embeddings here. So this is just the Hugging Face implementation of these embeddings. And like I said, these embeddings have been my favorite for a long time. And the only challenge with it is that this is a 5 gigabyte model. And when we come to actually make the embeddings with the database, this actually takes quite a bit of time on a T4. Right? You're sitting there waiting for a while because we've got about 1,000 pieces of text that we're actually making embeddings for. And so sitting there waiting for this takes quite a long time. If we compare this to the new one that I've done today here, the code is basically the same for all of this. The only thing that I've changed in here is actually the embeddings, right? So rather than using the HF InstructorXL embeddings, we're using these BGE embeddings. Now, like I mentioned earlier on, the model that I'm going to use is this BGE base EN, right, for English. We're going to basically use cosine similarity. So we're just going to normalize the embeddings as true. And then we can just set it up like this. And then when we come to using it with ChromaDB, we can actually just drop it in to the embedding like this. Similar to what we did before with not a huge amount of difference in the code here. Now, where it was taking quite a few minutes to process with the InstructorXL, you can see this whole thing was done in sort of 35 seconds for 1,000 embeddings in here. We then basically make our retriever just like before. Rest of the code is just like before. We've still got the sources. We're going to get basically return source documents equals true. And we can look at the outputs here. We see that sure enough, really the main thing is looking down here. Sure enough, it's finding the right outputs for each of these. Now, it is interesting that the language model itself is actually writing some other stuff as well. So I might look at making a video. One of the things you can do with this is do a second pass into the language model to clean up the output. So really probably we'd want just this, maybe with some of the explanation. We don't want the incorrect answer in there. For many of the others, it's okay. For this one, again, the language model is providing a bit of a strange output in that we're getting the correct answer first up, where it's basically telling us that it's been expanded from 2048 to 4096 tokens. But then we're getting this kind of weird stuff that's going on here. So this is what we'd want to clean up if we're doing this. With the other ones, you find most of them are pretty much fine. How many tokens was Llama 2 trained on? It was trained on 2 trillion tokens. All of that is fine. The sort of trick questions around when is Llama 3 coming? It's interesting here that basically says there is no official announcement from Meta regarding the release of Llama 3. Current version of Llama 2 was released July 2023. It's interesting that it's giving us a few other answers. Now, I'm guessing this is due to the actual system prompt and stuff that we're using in here, that we're just using the basic QA retrieval. So we could optimize that for Llama 2 and use their system prompt more and putting that together over going through this. Going through the others, you're going to find answers similar, outputs similar to what we saw before. So the big win here is not necessarily that it's, hugely better quality. We could go to the bigger model and perhaps get better quality retrieval, but actually we didn't have bad quality before. And this is something that you will see for a lot of these things. The huge win here is that rather than be 5 gigabytes, that this is only 438 meg for this actual model. So it basically means our inference time is going to be quicker. The amount of RAM that we need is less for VRAM, etc. on the GPU. You could probably even do the inference on this with a CPU, and maybe the time's not going to be totally awful for that. Anyway, so these are the new general embeddings, the BGE embeddings from the Beijing Academy of AI. You should certainly check them out. And if you're interested in embeddings for multilingual things, I would keep a very strong watch on when they release their multilingual models, because my guess is that you might see a nice bump in multilingual models. You might see a nice bump on the results for outputs for the multilingual models going forward. Anyway, check these out. As always, if you have any questions, put them in the comments below. If you find this kind of video useful, please click and subscribe. And I will talk to you in the next video. Bye for now.